So the topic for today class discussion is we will continue our discussion on bond arithmetic. So in the bond arithmetic calculation till now, in the last class we have discussed the calculation of duration. In duration, we have understood two types of duration. One was macular duration, and the other one is modified duration. So basically, the concept of duration, the concept of duration, how the concept of duration comes, like whenever you plot the graph between the price of the bond with respect to the yield till maturity of the bond, you have to understand that price is inversely proportional to yield till maturity. So whenever you find the relation between the price and yield till maturity, price is inversely proportional to yield till maturity. So logically, if the two variables are inversely proportional, then their graph should be like this. And when you get this graph, then you can see that this is straight line curve, and every straight line curve follow the equation of a linear equation formula. So because this is a straight line curve, so the equation of it, if you try to determine the equation of this straight line, then it should follow the formula called y is equal to a plus bx, where a is the intercept and b should be the slope. So here a is called the intercept and b is called slope. So the slope of this line, basically the slope of this line, the slope of this curve is the duration. The slope of this curve is basically the duration basically measures the rate of change of price with respect to the yield till maturity. So what basically duration measures? So the duration measures the rate of change of price. Duration basically measures the rate of change of price of the bond with respect to the with respect to the change in the respect to the change in the interest rate or yield till maturity in the market. So that is basically what the duration basically measures. So what we have observed while while correlating the value of the duration with respect to the normal market, we have observed that the small change in the interest rate bring the opposite change in the price, but larger change in the interest rate does not bring the larger impact in the price in the opposite order. Okay, so we have discussed the formula also. So we have discussed the formula also. DP means change in price is equal to modified duration into price of debt instrument into change in interest rate. This formula already I told you in the past. So whenever we talk about the change in price, so the change in price is equal to minus of modified duration into price into change in interest rate. So here you can understand that whenever the interest rate increases, the price of the debt instrument decreases. Whenever the interest rate decreases, the price of the debt instrument increases. But whenever there's a small change happens in the interest rate in the market, maybe 5% basis point or maybe 10% or 15% basis point. So if the small changes happens in the interest rate, you can see the opposite change in the price, but larger change in interest rate does not bring that change in the price. So that explains the logic that the graph what you see between the price and YTM, that is not a linear graph, but if you actually plot the graph between the price and YTM, instead of being linear, it is like this. Okay, and this relationship is called as convexity. This relationship is basically called as convexity. So whenever we talk about convexity, the formula for the convexity is basically coupon divided by 1 plus YTM to the power T into T plus T square coupon 1. That is basically coupon divided by, so that is coupon divide by 1 plus ytm to the power t into t plus t square. Okay. Okay, and this you will divide with 1 by ytm square. So this you'll do from your t is from 1 to n. Suppose the life of the debt instrument is n, plus face value into n plus n square, divide by 1 plus ytm to the power n into 1 plus ytm square. This divide by the price of bond. This divide by the price of bond. This is the formula of convexity. So the relationship, what we have observed, that whenever we see a small change in the interest rate, so if the interest rate increases by 10 basis point or something like that, then we can see the similar opposite change in the price, but larger change will not bring that significant change in the price. That shows that the relation between the price and the YTM is not linear. Instead of being that linear, that is actually convex. Okay, so I hope you understood this, and that relationship is measured by a mathematical formula that is called as convexity. So whenever we talk about duration, so whenever we are talking about duration is nothing but duration is the first order derivative of the change of price with respect to the change in YTM of the debt instrument, while convexity is the change in the duration with respect to the change in YTM of the debt instrument. That is basically the convexity. Okay, so if I do small numerical, although convexity numerical does not come in exam, just for a small example, just just one numerical to explain you this formula, because many people don't like mathematics. So it's simply for your formula. Suppose there's a suppose there is suppose there is 4-year bond. Suppose there's 4-year bond. Okay, having coupon percent of 8%. Okay. So YTM is equal to suppose 10%. Okay. And then 4-year bond, and the face value is suppose 1,000 rupees. So we'll do the calculation. So okay. So the coupon of this bond would be 8% of 1,000. So the coupon of this bond would be 80 rupees. Okay. So what is the calculation of convexity? So the convexity of the bond. So then the convexity of the bond is, so you write down the year 1, 1, 2, then 3, and then 4. So you have 4 year. What are your future cash flows? Future cash flow. So one is 80 now. So 80 every year you will get 80, 80. Then on fourth year 80 plus 1,000, get 1,080. Okay. So your YTM is 8%. Sorry, YTM is 10%. So your YTM is 10%. So the present value of cash flow. So the present value of cash flow is 80 divided by 1 plus 10%. This is 80 divided by 1 plus 10% square. This is 80 divided by 1 plus 10% to the power 3. This is 1080 divided by 1 plus 10% to the power 4. So you can write this. This is 80 divided by 1.1. This is 80 divided by 1.21. This is 80 divided by 1.33. 1.33. This is 8. This is 1080 divided by 1.4641. Okay. So if you see in this formula, so once this is the present value, just multiply with t into t plus square. So if you do this, so present value of cash flow into plus t square. So this means 80 divided by 1.1 to 1 plus 1 square. T means 1, 2, 3, 4 years. This is 80 into, this is 1 square is 1, 1 plus 1 is 2, divided by 1.1. This is 80 divided by 1.21 into 2 plus 2 square. Means 4, 4 plus 2, 6. 80 into 6 divided by 1.21. This is 80 divided by 1.33 into 3 plus 3 square. This is 9 plus 3, 12. 80 into 12 divided by 1.33. Then this is 1080 4 plus 4 square divided by 1.4641. That is 1080 into 16 plus 420 divided by 1.4641. Okay, so now you got this. Now what you do, present value of cash flow into, you found t plus t square and then 1 plus ytm square. This you want for all. So this is 80 into 2 by 1.1 into 1 plus ytm means 1 plus 10% square. So this is 80 into 6 divided by 1.21 into 1 plus 10% square. So this is 80 into 12 divided by 1.33 into 1 plus 10% square. This is 81080 into 20 divided by 1.4641 into 1 plus 10% square. So if you find this value, this is 80 into 2, 160 divided by 1.1 into 1 plus 10% means 1.1 square means 1.21. This is 86 480 divided by 1.21 into 1.21. This is 12 8s are 960 divided by 1.33 into 1.21. This is 108 8 8 2s are 16. The 21600 divided by 1.21 into 1.4641. Okay, now find this value. Now find this value, everyone. 1, 2, 3, 4. Your cash flows are 80, 80, 80, 1080. Your discounting rate is 10%. So this divide by 1 plus 10%. to the power 1. This you multiplied with t plus t square. This is t plus t square, and then you divide this by 1 plus 10% square. So you can see this is 120.21. This is 120.21. You can see this 120.21. This is 327.846, 327.846, then 596.084, 596.084, and then this is 12192, 12192.6. Everyone, you can check with calculator if you want. Okay, so now do the sum of this. So do the sum of this. So the sum of this 13236, 13236, 13236.8. Do the sum of this. So you get 13236.8. Okay, I need to divide this with the price of the bond. So I need, this is the sum. This is the sum of, this is the sum of t plus t square into coupon divided by 1 plus ytm to the power t divided by 1 plus ytm whole square plus face value into n plus n square divided by 1 plus ytm to the power n into 1 plus ytm square. This this is basically your numerator of the convexity of the bond, and this you will divide with the price of bond. you will divide with the price of bond. That is basically your convexity. So the price of bond I have not determined. I did direct calculation. So I need to determine the price of the bond. So this is the price of the bond. So I need to know these values. What is 80 divided by 1.1? That is 72.72.7273. This is the 72.7273. This is 66 point. This is 66.1157. This is 60.1052, 60.1052, and this is 737, 737.655, 737.655. So if I do the sum of this, if I do, so I'll get the price of bond is 936.603. This is the price of bond, 936.603. So the convexity of this bond would be, this is 13,236.8 divided by the price of bond. Price of the bond is 936.603. The price of bond is 936. That is 936.603. 936.603. So if you divide this, you'll get the convexity. If you divide this, you'll get the convexity. 14.1328. This is the convexity of the bond. So this is the convexity of the bond. 14.1328. Okay. Anyone, any doubt? So we have understood how to determine the convexity of the bond mathematically. What is the formula for that? How to determine that part? So this is the formula of convexity. Anyone, any doubt? Anyone, any doubt? Anyone want to ask any question? So you have understood how to determine the convexity, how to determine the duration of the bond. So the duration of the bond, if you remember, the maculae duration, when we talk about maculae duration, it is nothing but T into cash flow divided by 1 plus YTM to the power T, that you will do. So you will determine the present value of cash flow plus n into face value divided by 1 plus YTM to the power n. This is the maculae duration. And what is modified duration? So when we talk about modified duration, so the formula for the modified duration is nothing but, it is nothing but maculae duration. It is nothing but, it is maculae duration divided by the 1 plus YTM, that is modified duration. So we have understood what is macular duration, what is modified duration, how to calculate mathematically, and how to interpret logically. So you have to understand. So price and YTM, they follow inverse relationship, and that relationship is basically, it is a convex relationship. I hope you remember convex concave. So in physics, in your schooling, you studied two type of lens. This is convex lens. This is concave lens. Optics, you studied this. The kind of graph which is formed, real image, inverted image, virtual image. So that kind of logic we are using here. So that gives this name convex. So this is about basic understanding of the graph of the price of the debt instrument with respect to the YTM. I believe you have understood this and nobody have any doubt, okay, on this part. Now you see this question. This question, your exam for 8 marks. Mr. Karan purchased a par a bond with a face value of 1,000 rupees. Par a bond at par. At par means at par means your face value is equal to the price of the bond. Par means the your face value is equal to the price of bond. Hello, can you hear me? Hello, is I'm audible? Hello, can you everyone, can you hear me? Because just now electricity went away, so I'm using my mobile internet. Okay, so I hope there's no problem with my voice. Okay, so at par means the face value of a bond is equal to the price of bond. So you can see that so the face value in price is given to you 1,000 rupees. So the face value and price, that is equal to 1,000 rupees. So the face value and the price is equal to 1,000 rupees. The life of the bond is 5 years. So the life of the bond is 5 years. So the life of the bond is 5 years. Okay, so the life of this bond is 5 years. So the life of this bond is 5 years. So you bought this bond for 1,000 rupees, and the coupon, how much is the coupon? Coupon is 10%. So your coupon is 10%. So your coupon percent was 10%. So your value of your coupon would be 10% of 1,000 means how much? 100 rupees. So your 100 rupees is your coupon. Okay, the bond was called 2 year later for a price called 1,200. So what you did, you bought this bond for 1,000 rupees and you got 100 rupees coupon for the 2 year. And then after 2 year, what you did, you sold this bond for 1,200 rupees. So so after 2 year, you sold this bond for 1,200 rupees after 2 year. Then Karan then reinvest the proceed in a bond, selling it in a face value of 1,000. with 3 year to maturity at 7% coupon rate. Okay. Can you, is I'm audible? Can you hear me? Everyone? What about others? Shakib is telling that the voice is breaking. What about others? Hello? Hello? Is I'm audible? Can you hear me? Is my voice is breaking?